Welcome back everyone! So today we're going to be talking about placing buildings, just like an RTS. So the first step is to have a building following in the mouse. Then we need to check the placement of the building, so we know which place is adequate to place the building. The third step is if the placement is okay, when the player clicks, we want to place the building finally. So how can we check the placement of buildings? Well, we can use an Area 3D node, which is useful to check against collisions against the terrain, units and other buildings. But how can you check the terrain angles? To avoid placing buildings on slopes or on places that it should not be there. So one of the ways you can check for terrain angles is to use the Area 3D collision shape size, assuming it's a square, to check the distance of each collision ray points, so we know exactly where the building is. So the conditions to place a building are: free of collisions. We do not want collisions for other buildings, assuming they have a static body 3D, which will be detected by the Area 3D node. We also don't want collision for other units, which are kinematic bodies 3D. And we also do not want to clip against the terrain, which is a static body 3D. So we also need to check if the terrain is adequate for the placement of the building. So the terrain must be somewhat flat, and we can check this by using each corner of the Area 3D with a raycast. We also want all the raycasted points for the terrain angle check to collide with the terrain, so we have to make sure that the building has reached the ground. And then finally we can place our building. So also we're working with a simple shader to make the building placeable or not visually identified to the player by switching colors using the uniform instance color, which allows us to customize the shader per instance. So that is all we're going to be talking about in this video. Let's go ahead and jump in Godot to see how we can implement this. So I am back here on a clean project to just explain that concept. So I tried to implement this in a tutorial with our current project, the RTS project, but it turned out that the implementation is starting to get complex, and I don't think that everybody is interested in implementing to the RTS project. So what I'm going to do on tutorials next to this one is just try to separate and isolate what I'm trying to explain in a single project. So this makes everything much easier to talk into details, much easier to get along, and I think for everyone it's going to be a much easier time to understand. So let's go through our nodes here first thing. So we have here two nodes that have scripts, the player interface and the building placer. So let's see the structure of the building placer. So this guy is going to be responsible in placing buildings inside your game world. And all it needs is a node 3D, which is going to need its position on the base. This is the position that's going to get attached to the mouse. So whenever you move the mouse, that is where it's going to get attached. So you're going to have some kind of interface button, and whenever you press it, it's going to enter the building place mode. And this label here is just for us to keep in mind we are inside the building mode. So whenever you are placing here, I made some prints and we go through each one of them. So the first check is if our Area 3D of the building placer is colliding with something. So you can see whenever the blue square around the building collides with the map world, we get a message saying that the Area 3D is clipping against something. And this also happens whenever I place a building. So if I place one right there, you can see that it is also colliding with that static body 3D. So this also works for units and whatever you set in on the collision mask. So that is the first check. So the next check is whenever the building failed to raycast. So you can see whenever we get to the edge of the screen here, raycast a collision point for each corner of the box. And whenever that point doesn't find a mesh floor and it fails to hit something with the raycast, we are going to get an error that the raycast failed to hit the ground. So that is another check we are doing the raycast. The third check is if the raycast have the distance. So you can see if you take somewhere that is too acute like this, you see this smooth surface. whenever you place here, it's not allowed to place, and the reason it's not allowing me to place, it's saying it's not planar enough. So that is one of the distance of the raycast has not allowed me to place there because the height of them is not planar enough. So the distance of the y-cast can fail the check. So this turns out to be that it's not suitable to be placed. And of course you can adjust this as you want. So that is how everything works together. If I go here on the side view, I think if I disable the light you can see it a little better. So the Area 3D here on our building placer doesn't actually start from the bottom of the building, it starts from up here. So there's a distance between the origin of the building placer and the collision shape height position here. And this is intentional because this Area 3D needs to be free of the map collision static mesh. So by floating a tiny bit, it's just the same with the units from other tutorials. By floating a bit, we can say that the building is not colliding with the mesh on the floor, because if you place the collision shape right on the bottom, it's going to be nearly impossible to get a good placement. And this is also something you can tweak however you like and depending on the buildings you have. So let's talk about the shader for the building placer. So you saw that it was changing colors whenever we want to place the building. Whenever it's not able to place it, you can see it turns red, and whenever it's able, it turns green. So how that works is the shader I have assigned here is just a simple shader, and here is it. So what it does here is it has some flags here for the render mode. So we do not want ambient light, no shadows, no specular, diffuse tune, because this works a little different. You can see if I disable it how it looks. I liked the look of the diffuse tune. I think this adds to the transparency here. So the important part of the shader here is the instance uniform vector 4 here, which is our instance color. So this is a vector 4 color that it's assigned to this instance. So the shader what it does is right here we get the albedo from the instance color RGB, and the alpha is returned for the instance color alpha. So after you have applied this shader, it's going to appear on your mesh object a new instance shade parameters, and here you can actually see our instance color 1. And I'm simply adding this instance uniform. And you can see you can make something else with it. So that is basically how you can change the color of it to make it appear as something like this. And then you can grab this hex code, and on the script you can replace it on the instance color attribute. And you can get the path to the instance here by copying the property path. So whenever you open the script here and you place it, it's going to grab the property path for that instance color. And that is how I change it here. So if I go to the building placer code, you can see I want to turn the model green. I just set the parameters here on the instance color. So that is how you can edit the shader here. So this is the hex value for the color green and the red, which basically I just choose the color here and copy the code here. So that is all regarding our building placer. For the player interface is just a button, and a label here. And the code for the player interface goes like so. Player interface has the script. So the nodes we have the building placer here, the button and the label. So let's talk about the interface mode here, which is quite important. So when you have an RTS, you have mixed inputs. So the left click is used to select units, but it is also used to place buildings. So the way I separated that was by creating a variable called interface input mode. So whenever I want only units to respond to that input, I have placed here at a 0 as a preview. So I know that if the interface input mode is 0, I am on unit mode, and if it is on 1, I know that I am on the building input mode. So that allows us to filter the inputs. So you can see here on the input function from the player interface, I have if interface input mode is equal to 1, so I know that I am inside building mode. So that is one of the ways you can do to separate the inputs. And this right here is just a simple set get that I'm doing. just almost like the previous tutorial. So the set get is basically telling, if you want to change this variable, what else do you want to do? And this is what I wanted to do. So you start the set get by giving a set, and it's going to ask what you want to do with a new value you give to this variable here, and I want to assign to the variable here. But I also want to update the interface to the current building mode. So if our interface input mode is equal to 1, that is a implicit cast here, but you can basically do this is the same thing. So if our interface input mode is on the building mode, I want to display the interface, the label that tells me I'm on the building mode. And I also want the node building placer, so this guy right here, so its collision shape to be activated. So you can disable or enable the collision shape, and so it's going to actually disable it. So I'm just grabbing the node building placer and enable its area 3D. And enable area is just going to set the collision shape disable to false or true depending on what I want. And that is how it works. So if I'm not on the building mode, what I want is to hide the node building placer, so it's this guy. I want to hide it. I also want to hide the interface label building, so the player knows he's no longer on the building mode. And I also want to disable the area for the node building placer. So that is whenever I set the interface input mode. So when we start our game here, I set it to 0 by default to start in unit mode. So it's going to hide all the building mode. And here's the code for the interface button. So the button here for the interface is being connected to a simple function. This is a lambda function. It's basically generates a function on the fly here. This dispenses the need for you to create another function just to call and connect here. So I am generating this function, which basically is setting the interface input mode to 1. So whenever you press that button, you're going to set the interface mode to 1 up here. Then you're going to also update these things here. That is the power of the setGet method. Otherwise, I will have to do all of that again here. So the important part comes here on the physics process. So whenever we are inside the building mode, so on the unit mode, this code is not being called. We are grabbing the mouse position, the global mouse position, and the current active camera for the viewport. Then we're going to start to project an array. So this raycast here is for the building to snap to the ground. So if I run the scene, I can show you what it does. So the building fall on the mouse position is through an raycast to the camera against the terrain. So the ray from is where you want the raycast to originate from. And you can originate the ray from the camera by doing a project ray origin to the coordinates 2D from the camera you want. In this case is our mouse 2D global position. Then you want to set up the target to the raycast, which is ray 2 here. And it starts from the ray from and goes to the camera ray normal. So this is basically telling the location that the camera is looking. Then you also want to multiply the raycast length by 1000. So this assures us that the raycast is going to hit something. Otherwise it's too short. For the ray parameters here, what is important is the starting position and the target position. Ray parameter here, you can also change the collision mask, which you want to hit only the terrain mask. And this is just for continuity with the previous tutorials that we set the terrain to be on layer 2. And this is one of the ways you can do it. So this is collision mask, which basically is inverted. So it starts here from the collision mask 1, this is the collision mask 2, and the next one will be the collision mask 3, the next one will be 4. So you can set to 1 or 0 to true or false. Then next we want to actually cast the raycast. So the raycast result variable here is a variant because it can hit something or not. So the ways you can do this is by getting the word 3D, the direct space state to intersect array. And it's going to ask for a raycast parameters, which is everything we passed here. So if we hit something, in this case if we hit the map mesh, then we're going to ask if our node building placer origin is not the same as the raycast position. So the node building placer node is this guy here. So we want this center position here to be where the mouse hit something on the map. So if that's not the case, we want to teleport the node building placer to the mouse raycast position. And I also want to display the node building placer. So it's going to be hide up until the moment that it finds somewhere to place it, then I'm going to display it. So if we can actually place the building, then we're going to save the location of that raycasted position. And we're going to say to the interface that we can actually place the building there. And whenever we change the position of the mouse, and this condition is no longer workable, so you can say that the building is no longer placeable, then you're going to say that we cannot place the building there, and we also are going to reset the building place location to 0. This is the same thing if our interface mode is not on the building mode. We want to do the same thing as we cannot place the building, so it's going to disable any chance for us to place the building. So for the in-player interface input events, so if we are inside the building mode and we can actually place the building and the building place location is not 0, then we are going to load and place the building. And here you can actually start some RTS building stuff like placing blueprints and stuff. This is the way that I'm loading the building here. First I get the package scene by loading that resource. And that scene looks just like this. So it's just a node 3D on the center with the building mesh on top of it, aligned here on the same place as the building placer. Then we are simply creating a static body 3D to collide with other buildings. But this is going to be your mesh for the collision of the building that you're probably going to import from Blender. So we load that building scene, then we save it under as a package scene. Then we grab the building node as the building package scene instantiated. Then you are going to get the parent from this node. So this code belongs to the play interface, so I am adding it through the world here. So, and we're going to grab the world node and add the new building, which is the building node. Then I'm setting here the building node transform origin to the building place location, which is saved from the physics process, which checks for the placement check here. So if you wanted to rotate buildings or that kind of stuff, you basically can save that as a transform instead of just a building placer location. And you can say create some type of inputs to rotate the building like key or U or some kind of arrows. So you're going to save that information as the building placer transform. And whenever you want to assign that rotation from the building placer to the building node, you can just assign here as a transform instead of just the origin, because just the origin is just the position of the transform. So that is how you can assign a rotation to the building. So now let's go through the script of building placer. So the placement check function is going to be a boolean check, and by default is going to assign our model to be red. And whenever everything's successful, it's going to assign as green and return true. So we are looking for false if we cannot place the building. So the first check here, if our area 3D has overlapping bodies, and we are going to return false if that is the case, because we do not want the building to be colliding with anything. And if you want to change what the area 3D can collide, you can simply change the collision mask for your area 3D. So we're going to start by saving the area 3D collision shape node, which is a box shape 3D, which in this case is grabbed from the area 3D collision shape node and get shape. So we know that the area size is equal to our collision shape size divided by 2. And here are the points we are going to check. So this is for each corner of the box. So we are projecting a raycast from each point of this raycast box here. So each corner of this 3D area 3D here, we are saving its size here, and we are checking a raycast from each of that position. So this is the starting position for the raycast. Then next we want to store all the distances in Y inside an array, so we can later check if we are in a planar place or not. So now we are going to start to raycast for each point we saved earlier here. So for each point, we are going to project and raycast, and just like the raycast from the camera, this is the same structure for the raycast. The raycast is going to start from where? From the points to check are arrayed here using the Y. So it's going to start first on 0. It's going to go where? From the start position to downwards -20. Then next we're going to pass the ray parameters and the ray starting position, the ray goal, and the collision mask for the raycast. So we only want the terrain, which is the same as the raycast from the camera on the previous one. And the raycast result, which uses the parameter, then we're going to say, do we actually hit something? So do you hit the map mesh? If so, then you're going to save the distance. So if the raycast points did not find the floor of the map mesh, we can say that the raycast failed to hit the ground and we're going to return false. So we did not found a place to place our buildings. So if we collided with the ground, then I'm going to save the Y distance. And the Y distance starts from the ray from Y position to the raycast collided Y position. Then I'm going to simply append that Y distance inside our array for Y distance for us to check later. So this is going to run through all the 4 points inside our area 3D collision shape. Then next you're going to check if the Y distance for the Y distances array is higher than something we set. So if the distance from a collision point to the ground was higher than a given value, we know that the floor is not planar enough. And we can say return false here, because one of the foundation corners are way too much lower. And you can change this condition here to something you want. So if you want buildings to have a much more planar surface, you can reduce this value here. I just put it to here just as a test for this project. So I am basically invertly checking if I can place a building. And if any of those conditions failed, I'm going to return false. However, if after everything we checked, any of those conditions proved to not be true, then we're going to simply say that every condition passed, so we can allow the building to be placed. So I'm going to turn the model green and return true for the placement check. And this placement check is used on our player interface script here on the physics process. So you can see here, so if we can place the building, then we're going to save the location where that building was successfully passed the placement check, and we're going to say that we can actually place it. So when you release the left mouse click when inside the building mode, we can check if we can actually place the building if the building placing location is different than 0. If so, we can finally place the building. So that's everything you have to work to get this right here. And I have an issue, and I just disabled the building preview here. And I have issues with the input events from the shift command, which is not supposed to be called, but is somewhat being called, and I don't know the reason of it. So unhandled inputs is something I'm going to tackle in another tutorial because it's something complicated to explain here. So that is how you can make a system to place any buildings you want. And if your building is round, you can simply place it inside the R3D and work with the box collision shape just the same. Here you can see it in action. We can select our units, tell them to move somewhere, then we can go ahead and place a building. And after placement of the building, then we skip back to the unit mode, and here we go. So something I have on my to-do list is currently I'm using a navigation obstacle, but I don't like how it's working here. So instead of that, what I'm going to do later is to, after placing the building, I'm going to rebake the entire mesh on while the game is running, so the navigation agents work much better around buildings. So that is for my to-do list. But as you can see here, we can switch between building mode and input mode. So as you can see, whenever we place a building, the units change. And keep in mind the navigation here you are seeing is on 4.03. There is still a lot of improvements on Godot when we change and you can see they actually change because the navigation here is updating. So when you are updating to Godot 4.1, which currently is on beta, I think, you're going to see a lot of improvements to the unit navigation system. So you can see everything works nice. I have the camera input not interfering with exiting the building mode. Whenever I press ESC, I skip the building place mode. If I have a selection, I enter on the building mode, it's going to deselect all the units. And this actually is a bug because if we want our units to work on this, you should not clear the selection. So this is something that I will do later. So you can see that the implementation can change depending on your project. That's why I decided to keep it out of the YouTube RTS project that we were developing. And some of you guys suggested that I post the assets and the project files. And I think that is a valid request, especially since everything was scrapped inside a single project. So now I try to isolate the concepts so they are a little easier to understand, a little easier for me to do it because I don't have to worry about the implementation details, but it's also faster to make the videos because otherwise I have to show in the video how you can implement everything together, and that is another issue alone by itself. So I hope you guys enjoyed the video and I'll see you on the next one.